squeeze limit theorem to find the limit of a particular function. So suppose that x plus 2 over x plus 3 is less than or equal to some g of x, which is less than or equal to x squared plus 5x plus 6 for all x in the domain from -3 to 3. Let's say we wish to find the limit of x approaching to -2 of the function g of x. Now we have no idea what g of x is, but we know that g of x is sandwiched in between the function here on the left and the function here on the right. So hopefully that will provide us enough information to be able to tell what the limit of x approaching -2 of g of x will be. Okay, let's see. Well, notice that on the left, x plus 2 over x plus 3, as x approaches -2, is going to limit towards -2 plus 2 over -2 plus 3. In other words, it's going to limit to 0 over 1, which is 0. Furthermore, on the right, x squared plus 5x plus 6, as x approaches -2, what's going to happen over here? Well, over here you'd see that you would get -2 squared plus 5 times -2 plus 6, which is 4 minus 10 plus 6, which is actually also 0. So now notice that the g of x function is located in between these two functions, and the function over here limits towards 0, and the function over here limits towards 0. So therefore we can conclude that even though we don't even know what g of x really does in generally, we know that limit as x approaches -2 of g of x must be equal to the number 0, because it got squeezed between 0 and 0. Okay, now take a second and try this one out. The limit as x approaches 3 of x minus 3 to the 4th power sine of 3 minus x plus 4. Assuming that you took a moment out here to try to do this on your own, let's look at this from a squeeze limit perspective. So notice that we have, first of all, sine of 1 over 3 minus x. I'm going to concentrate on that part, because the sine function, sine of 1 over 3 minus x, is always going to be bounded between -1 and 1, right? Because the sine function itself is always bounded between -1 and 1. So therefore, x -1 times x minus 3 to the 4th plus 4 will certainly be between x minus 3 to the 4th sine 1 over 3 minus x plus 4, which will be lower than 1 times x minus 3 to the 4th plus 4, right? Because since -1 is always less than or equal to 1 over, or to sine, which is less than or equal to 1, then multiplying by x minus 3 to the 4th and adding 4 will still maintain that inequality. But now notice that if we overall take a limit as x approaches 3, what's going to happen here? Well, on the left-hand side, 3 minus 3 is 0, 0 to the 4th is 0, 0 times -1 is 0, and so we get a 4. And on the right-hand side, far right-hand side, 3 minus 3 is 0, 0 to the 4th is 0, 0 times 1 is 0, plus 4 is 4. So what we can see is that 4 is less than or equal to the limit as x approaches 3 of x minus 3 to the 4th sine 1 over 3 minus x plus 4, which is less than or equal to 4. So literally it has to be between 4 and 4, and therefore this limit right here must be the number that's located between 4 and 4, which is just 4, and that's the sandwich theorem.